Action.
Alright, so we are Don's Engineering, and this is the greatest machine ever. And I'm Jared.
I'm Deiudonne.
And I'm Blaine.
So for our design brief, we have to, it's for mainly at the construction audience where people build stuff and they need help lifting up heavy objects. And here's some of our prototypes and our ideas.
Okay, so right here is the greatest machine ever Mark III. There are 3 different versions of it, but they all follow the same general design. And by general, I mean we still have the pulley and the wheel and axle. So the first one, the top one, that was supposed to be a lever, but we figured out the lever wasn't long enough to get this to go all the way up, and then we decided, oh, we just spin it around enough, it'll get up there. But then at that point, we just made another wheel and axle with a nifty little handle, and then so then we got the sprocket and chain system, which now spins this, lifting this, and yeah, that is the greatest machine ever, Mark III.
For our decision matrix, we had 3 sketches, but the first one is like the general idea of what we wanted, and Blaine came up with that, and then me and him and Jared made different models, like with different pulleys. This one had 3, this one had 4, and that one had an incline plane. But TGME1, so
Yeah, that's the abbreviation for it. The greatest machine ever.
Alright, so our final sketch here was this part being the handle that you would turn, turning the sprockets and chain, and then it would spin the wheel and axle here, which then the string attached to the pulleys would wrap around this smaller wheel right here, and it would pull the weight up to the 12-inch mark.
we're drawing it down.
Yeah, Deiudonne drew that. He's a good artist.
Okay, and then here's just a video of our machine.
Oh, go back. So now you see it again at work. It's about to pass the 12-inch mark. We are? Oh, there we go. Yeah, we go past it. We could go further. As long, like, if we were allowed to go higher, we can adjust this. It'd be really easy. We just have to take this off, slide it out, and then make this tug and slide it back in. So it's a really simple design. It wasn't really that hard to make. And now for calculations, I'm gonna go over here. Take a good look. So the IMA for our pulley was 3, since it has 3 supporting like strings. It goes through here, here, and here. And then the IMA for the wheel and axle is 1.5. The IMA for the sprocket and chain is 1.2. And this gives us an overall IMA of 5.4. And then the AMA turned out to be 1.9. And then when we calculate our efficiency, we got 35%, which compared to other people's today, we're doing okay. we're not 69, but we're not a 10. Or 5.
That is mean.
Just poking some fun. Oh yeah. Does anyone have any questions?
What practical purpose would you
So
use it for?
basically, this is a crane. We've redesigned the crane, is what we did here. Because an old crane, I don't know how cranes work these days, but like one from the industrial era, they would use something. Well, they use this part. Is just the only thing that's different from back then is that we use this, and they probably had some motor to actually spin this to pull this up, and theirs could move left to right, which give us enough time, we probably could design that as well.
You're not getting any more time. Anything else? Okay.
Thank you.
John?